Newton's second law, F is equal to dp upon dt, d upon dt mv m dv dt plus v dm dt. Linear momentum P is equal to mv. For constant mass system, F is equal to ma. Momentum it is the product of the mass and velocity of a body, that is momentum. P is equal to mv. SI unit kg meter per second. Newton's third law of motions, whenever particle A exerts a force on another particle B, B simultaneously exerts a force on A with the same magnitude in the opposite directions. F A upon B is equal to minus F B upon A. Now a spring force according to Hooke's law in equilibrium, F is equal to kx. K is a spring constant. Natural length. A spring force is non-impulsive in nature. Laws of motions and frictions. Motions of body in the contact. When two bodies of mass m1 and m2 are kept on the frictionless surface and a force F is applied on one body, then the force with which one body presses the other at the point of contact is called force of contact. These two bodies will move with same accelerations. When the force F acts on the body with mass m1 as shown in figure, F is equal to m1 plus m2 in bracket A. When the force F acts on mass m1, if force exerted by m2 on m1 is F1 force of contact, then for body m1, F minus F1 is equal to m1a. FBD representations of actions and the reactions forces. For a body m2, F1 is equal to m2a. Actions of m1 on m2, F1 is equal to m2f upon m1 plus m2. Now, pulley systems. A single fixed pulley changes the directions of force only and in general assumed to be massless and frictionless. Let m1 is greater than m2. Now for mass m1, m1 g minus t is equal to m1a. For mass m2, t minus m2 g is equal to m2a. Accelerations a is equal to m1 minus m2 in bracket upon m1 plus m2 into g. Net pulling force upon total mass to be pulled. Tensions T is equal to 2 m1 m2 upon m1 plus m2 into g is equal to 2 into product of mass upon sum of two mass into g. For mass m1, T is equal to m1a. For mass m2, m2g minus T is equal to m2a. Accelerations a is equal to m2g upon m1 plus m2. T is equal to m1 m2 upon m1 plus m2g. frame of reference, inertial frame of reference, a reference frame which is either at rest or in uniform motions along the straight line. A non-accelerating frame of reference is called an inertial frame of reference. All the fundamental all the fundamental laws of physics have been formulated in respect of inertial frame of reference. Non-inertial frame of reference. An accelerating frame of reference is called a non-inertial frame of reference. Newton's law of motions are not directly applicable in such a frame. Before applications, we must add pseudo-force. Pseudo-force, the force on a body due to accelerations of non-inertial frame is called fictitious or the apparent or pseudo force and is given by a naught is accelerations of non-inertial frame with respect to an inertial frame, and m is mass of particles or body. The directions of pseudo force must be opposite to the directions of accelerations of non-inertial frame. When we draw the free body diagram of a mass with respect to an inertial frame of reference, we apply only the real forces which are actually acting on the mass. But when the free body diagram is drawn a non-inertial frame of reference, a pseudo force in addition to all the real forces has to be applied to make the equations equal to F is equal to ma to be valid in this frame also. F real plus F pseudo is equal to ma, where a is the accelerations of object in non-inertial reference frame. F pseudo is equal to minus ma, where a naught is accelerations of non-inertial reference frame. Frictions is the force of two surfaces in contact or the force of a medium acting on a moving object, that is air on aircraft. Frictional force arises due to the molecular interactions. In some cases, frictions act as a supporting force, and in some cases, it acts as an opposing force. Causing of frictions. Frictions arise on account of a strong atomic or molecular forces of attractions between the two surfaces at the point of actual contact. Means in a lift, if the lift moving with constant velocity be upward or downward, in this case there is no accelerated motions, hence no pseudo force experienced by observer inside the lift. So apparent weight W is equal to mg, actual weight if the lift is accelerated upward with the constant acceleration a, then force acting on the man with respect to observed inside the lift are weight W is equal to mg downward, frictious force F naught is equal to ma downward. So apparent weight W dash is equal to W plus F naught, mg plus ma is equal to m in bracket g plus a. If the lift is accelerated downward with accelerations g is greater than a, then with respect to observer inside the lift, frictious force F naught is equal to ma acts upward while the weight of the man W is equal to mg always acts downward. So apparent weight W dash W minus F naught is equal to mg minus ma mg minus a special case if a is equal to g then W dash is equal to 0 conditions of weightless mass. Thus in the freely falling lift the man will be experience weightlessness. If lift accelerates downward with the accelerating a is greater than g, apparent weight W is equal to mg minus a is negative, that is the man will be accelerated upward and will stay at the ceiling of the lift. Types of frictions: static frictions, no relative motions between objects. Kinetic frictions, there is relative motions between objects. Graph between applied force and force of the frictions. Static frictions coefficient. Kinetic friction coefficient. Angle of frictions. Angle of repose, the maximum angle of an inclined plane for which a block remains stationary on the plane. Maximum angle of an inclined plane for which a block remains stationary on the plane. Dependent motions of the connected bodies. Method 1. Method of the constraint equations. For n moving bodies, we have x1, x2 and so on as a xn. Number of the constraint equations, number of a string is equal to number of a string. Method 2. Method of the virtual work, sum of the scalar products of tensions forces applied by the connecting links of constant length and displacement of corresponding contact point equal to 0. Normal constraint, displacement, velocity and accelerations of both objects should be same. Key points: aeroplanes always fly at low altitudes because according to Newton's third law of motions, as aeroplanes displace air and at low altitude density of air is high. Rockets move by pushing the exhaust gases out so they can fly at low and high altitude. Pulling is easier than the pushing on the rough horizontal surface because normal reactions is less in pulling than pushing. Figure 1 is indicating figure 1 for pulling and figure 2 for pushing. Well, walking on ice, one should take a small step to avoid slipping. This is because a smaller step increases the normal reactions and that ensure a smaller frictions.